Sonia's spot. Lisa Pratt, you are the Planetary Protection Officer for NASA. There's only one other person with a job title as cool as yours. That's Lindley Johnson, the Planetary Defense Officer, one of your NASA.
Goodness, that's not part of my responsibility. I usually have to, the very first thing I have to tell people is I'm not the one watching the near-Earth objects and worrying about a collision.
But we did hear on this panel, you largely talked about the part of your role that has to do with protecting our own planet Earth. I'm going to go on to protecting Mars, but first, just to mention a little bit of this, I mean, not surprisingly, you're listed on the NASA website as an astrobiologist, but what is a Bio Geochemist?
Well, a biogeochemist is somebody that does research right at the disciplinary boundary between the traditional disciplines of biology, chemistry, and geology. So that is a field that really has only sort of emerged in the past, say, 10 to 15 years with the recognition that many of the most challenging unknowns, many of the knowledge gaps reside between the traditional disciplines.
One of the slides that you presented with the panel a few moments ago, Sonia's panel, I think was a great illustration of this because it showed us sort of a cross-section of the Martian surface, what we think may lay below the surface, and how close to that surface might be the liquid water that we know life needs to survive.
That is a really important point. We don't know where the liquid water boundary is on Mars, in part because Mars has extreme orbital obliquity. So Earth has a tiny little wobble of a few degrees, and yet that drives glacial, interglacial climate change. Mars goes from its present very modest obliquity, very similar to Earth's, to single-digit obliquity, and then can roll over all the way to 60 or 65 degrees. And when it's in extreme obliquity, and we think that might be about every 100,000 years, the planet is fundamentally different. And so it is a planet that is seasonally warmer than the present day. The water migrates from its current polar ice caps into low latitude areas, and we think that's when there would be an opportunity, if there was a Martian organism that had evolved in this extreme obliquity variation, that it could get through the cold, dried spells like the present day and be ready to reemerge under better conditions. So it's a really important aspect.
We know now, thanks to our flotilla, the armada of spacecraft above and on the surface, that Mars was, billions of years ago, a place that could have supported life. We still don't know if it's actually there, but we have to assume that it may be, or that it did exist in the past.
I think so. I think that's why I use the word prudent. We have a responsibility to life on Earth to be cautious about first contact. First contact only happens one time. It's like first date. You don't get a redo. And I think we need to think very carefully through. We may have already carried problematic terrestrial organisms to Mars because we can't fly a sterile spacecraft. So with that in mind, we need to be very, very thoughtful about how we bring samples back to Earth from Mars until we have a very high degree of confidence that there isn't anything biologically active. If there turns out to be life on Mars, then we need to decide, does it in any way present a hazard for life on Earth? Or is it that we're actually closely related because life originated on one planet or the other and inoculated the other location?
Which is a concept that we talk about on my radio show periodically, that maybe we're all Martians if you go back far enough.
From my perspective, I can't think of anything more wonderful than to meet the Martians and find out that they're relatives. I think that would just be, I just think that would be glorious.
You also made the point during your presentation that we still have a lot to learn about life on Earth. And so it sounds maybe even a little presumptuous for us to think about how we're going to find and maybe protect life on Mars.
I completely agree. I think that we're going to be challenged to recognize life if it, like some of the organisms on Earth, is small and not easy to visually identify or to grow in a laboratory setting. So we're going to have to, we're going to have to pull out all of our very best tools. And I think one of the other panelists made a very good point about our emerging microchip kind of technology where we can sequence not just the DNAs, RNAs, or XNAs, but we learn to identify and characterize other macromolecules and other biopolymers that we could easily imagine a successful Martian organism would need to survive that environment. So we can start to do synthetic Martian biology. We can do computational chemistry that gives us examples, analogs, that we can then test against, say, a sterilization procedure to see if it would denature something that we could imagine would be something produced by an extraterrestrial.
That's a bit mind-blowing. You're talking about alternatives to DNA and perhaps to proteins that we know make up life on Earth?
I think most of us assume that it would be hard to get away from protein. It might be a protein based on a different suite of amino acids or a different, handedness than life on Earth. I think more in terms of the kind of resistant, resilient biopolymer that an organism could cover itself with to minimize UV damage or damage from the harsh oxidizing or ionizing environment. So I think of it more as the coating around the exterior. On the interior, I assume that it will follow the same basic rules of biochemical reactivity that we have on Earth.
So maybe tough little critters if they're up there, and yet we go to great lengths to protect them. You surprised me backstage because I knew that Curiosity, the current rover on Mars, is being very careful about where it goes, has been very careful, no damp spots, because we know it wasn't perfectly sterilized no matter how hard JPL might have worked. But I thought that the 2020 rover launching next year was going to be in better shape, would be looking for those damp spots.
No. I think I'm glad you told me about that because it's a misconception that I need to make sure we're addressing. There are the same restrictions on the Mars 2020 rover that are on the current Curiosity rover. Now, what's different for Curiosity is it's been on Mars long enough that we might consider giving it credit for the biocidal processes on Mars and say it's now much cleaner than when it landed. And if there was an opportunity to look at a location that might have water vapor or movement of water, either day, night, or seasonally, it could be proposed by the rover operators that they be given permission to go in on the basis of the rover being orders of magnitude lower terrestrial bioburden than when it started. We've never been asked that question. I think...
Are you listening, JPL?
I think the international community would welcome the opportunity to address that question because we would want to do that by international consensus. It wouldn't be a NASA-only decision.
I hope you get that call from that international team that is still rolling across Mars with Curiosity. Okay, we'll finish with this, and it's the biggest challenge to the Red Planet, and maybe your biggest challenge. If we're going to put boots on Mars, those boots are going to be carrying all the nasty stuff that we humans have inside us and on us. How do we protect the planet then?
Well, that's a completely different, that's a different environment than we're in now scientifically. I would say the single biggest unknown on Mars is whether or not terrestrial life that would leak out of our space suits or leak out of our vehicles, that it can get onto the Martian dust and be moved across the entire planet. So if we could limit the human contamination or the human associated contamination to just the exploration area, I think we could manage that. The problem is we don't know whether or not we could manage contamination that is vectored by the dust. So we're actually, NASA and many other space agencies are putting increasing funding into modeling and doing wind tunnel aerodynamic studies of Martian dust analogs, because we need to know. And then we need to know, really, whether or not a terrestrial organism of any of the ones we've tested, could a hardy resting cell, could a hardy spore, get onto that dust and be moved unintentionally to a damp environment?
Just a couple more, because out of that I have to ask, you must be aware of the exploration of using spacesuits that never come inside the human habitat, that you sort of jump into through the wall, they seal the door behind you, and you're out on the surface of Mars.
The problem is all of those spacesuits have joints, because you have to be able to move and walk and turn your head. And so a lot of research right now associated with the Planetary Protection Office is looking at sampling, swabbing, wiping, and characterizing how much of the human biome gets across the leaky sites. So hopefully, eventually, we'll have a spacesuit that really has little or no leakage. But right now, we don't have that magic wand. So it's a big concern. You're stepping on something that makes my foot hurt.
So see if this makes your foot hurt or cringe or did it. When you saw the movie The Martian, which my friend Andy Weir, with his potatoes and all the other nasty stuff he used to grow them, and then he was single-handedly infected the planet. Yeah. Did that just have you cowering in your seat?
No, for me, that movie is so emotional because I wish I was the one there. So for my family won't even let me watch that movie, because all I have to do is see the opening scene, and I just have tears running down my face, and they're like, "Oh, Mom, you're just, you'd go, wouldn't you?" And I go, I'd go on a one-way ticket.
I'll go with you.
Because, I think I'm at an age where I've done what I can do on Earth, and the chance to be an explorer on Mars would be absolutely irresistible. Thank you.
I've promised my family I won't do the one-way trip, but I would love to go with you if I have a trip back as well.
Let's go together.
Thank you. Look forward to it. Hope we get the shot. Thank you, Lisa. All right, that was Lisa Pratt, the Planetary Protection Officer for NASA and for our planet, and for that matter, for all the other worlds across our solar system. It's her job to make sure that we take care of all of them.